This is supervised learning versus unsupervised learning. Okay. Supervised learning, you have labels. Like you know that these are circles. The points here are X, okay, or cross. And you want to draw a line that can separate these two classes, class 0 and class 1. But in the case of unsupervised learning, everything will be like a black dot. You don't know like which side is which class and so on. And you want to learn it on your own. Okay. Can you give me any examples for unsupervised learning? Examples of unsupervised learning where you don't have any label information. You want to learn the labels on your own. Like if you look at this figure, there is something called recommendation system. There is something called customer segmentation and so on. Okay. In the case of, let's say, customer segmentation, let's say you are going through the Amazon website and you see some recommended products for you, right? How does the system know like what a product you're going to buy or what's the most likely product that you're going to buy? Okay. There, people use unsupervised learning. Okay. They don't have any information on your preferences beforehand. So they try to see what all products you bought before, what all uh, you might be buying. That is the class label. Okay. So they have this information and they want to cluster it accordingly. So this is where clustering comes. So what is clustering? It's dividing the data points into different number of groups. Okay. And the main concept here is points belonging to one group will be very similar to each other than points belonging to another group. Okay. Mm, applications, yeah, market segmentation, shopping preferences, social network analysis, and so on. So there are two main approaches for clustering. Okay. First approach is you classify all data points into separate clusters and keep aggregating them. Or you classify everything as single cluster and based on the distance between the points, you partition into separate clusters. Okay. Maybe I'll show some examples. Okay. Clustering models, there are different models. One is based on centroid, one is based on distribution, one is based on density. Centroid models, meaning you randomly pick some data points. You start pulling nearby data points into a cluster centroid. Okay. Distribution models, it's based on probabilities. Okay. Again, you don't need to go in depth on the mathematics involved and all distribution methods and density methods. Okay. Yeah, and this is based on probabilities and this is based on probability density. There is a difference between distribution and density. So I hope you know the difference. Okay. See, and there are different clustering methods mentioned here. Okay. We'll be looking at k-means, hierarchical, agglomerative. Okay. K-means is the most widely used clustering method. And yeah, it depends on different use cases, whether inductive, transductive meaning, inductive meaning, what happens is if you have some other data point, okay, some other data point that is not present before clustering, if it comes in the picture, will you be able to assign a label for that or not? Okay, that is what inductive and transductive mean. Okay. every implementation is available in scikit-learn. Okay, so you don't need to worry about it, and you don't need to know the mathematics behind these things also. Okay? If you just know how to implement it, for now it's fine. But if you want to get into the details, how it works and so on, you need a bit of a mathematical background to understand all these things. Which I mean, I won't be providing in this course. I'll be only focusing on the implementation part. Okay. So how does k-means clustering work? First, you have to decide the k that you want. In the case of clustering, what should be the k? Anyone? What should be the k? Okay, let's look at this image. What should be k here in this image? What should be the k here? K meaning
Number
number
of
of clusters.
clusters.
Yes. And what should be the k value here?
2.
Yeah, 2. If you set it to, that is also an important thing that you have to set beforehand, okay, by looking at the data. If you set it to 3, it might not be good because there are only 2 classes, okay. So you have to design k, and based on that, assign any random point as centroids, okay. Then you have to calculate distance, okay. And so what you and assign the closest points to whatever cluster that you have. Maybe if I explain it like this, it won't be that much intuitive. I'll show it in the next slide. What happens? You calculate mean, assign difference centroid, then do the steps again and again. Okay. See. What should be k value here in this figure? What should be k here? It can be 2. Okay, it can be 2, can be 3, can be anything. Here I've decided to keep 2. Okay. I'm picking these 2 points as my centroids in this. Okay. Then I'll see if this point is closer here, I'll assign it as blue. If this point is closer to this red point, I'll assign it as red. So I've assigned everything as red and blue. Okay. The next step, what I'll do is calculate the centroid. Centroid distance, maybe I'll explain it during the programming assignment how to calculate it. But yeah, you take the mean of all the coordinates of these points. Okay. Then what will happen is this x will change. See, it has changed from here to here and from here to here. Then what I'll do, based on this, I'll keep assigning blue and red again. I've assigned it again. Then I'll take the mean, okay, and see how my centroid moves. It has moved here. Blue has moved here. Okay. Then again I'll take mean. Again I'll calculate distance. It has moved here. It has moved here. So basically there is, if I calculate centroid again, it will move here. It will keep moving here only. Okay. And there won't be any change in the classes. See. Now when there is no change, you stop. Any doubts in this? Or should I explain it again? Just take in, just go through the sequence. Okay. How the centroid moves and everything. Okay. And let me know if you have any doubts. Do you think of do you think this is somewhat similar to some other algorithm that we were discussing before? Similar to k nearest neighbors, right? Like whichever point is closer to that point, it will be it will be assigned to that class or so on, right? Very similar. Okay, but here you have to decide k before, then proceed accordingly. Okay. So obviously what will happen is if you choose first thing is local optima, okay? Local optima meaning this can be one solution, this can be one solution. So the initial point where you keep the centroid, okay, that can change. If you keep it like this, it's perfect. You can have three clusters. If you keep it like this, if you keep it like this, it's not proper. If you keep it like this also, it's not properly clustered. So where you place the point, okay, that is an issue. And then the next issue is choosing the value of k. See here, if I choose k as 3, small, medium, large, that can be my t-shirt sizing. If I choose it at 5, see there are 5 different clusters like this. We don't know actually what is the proper number of labels. That is also another disadvantage. And this only seems to work well when clusters have a spherical shape like this. It can be put into circles. If it's not having a shape, see if this is not a proper circle, okay, then that will be a problem again, where k-means clustering won't work. Okay. Any doubts in k-means clustering? Okay, so there are no doubts. Moving on, how to select k. Okay, what you have to do is you have to calculate the sum of squared distance. Okay, what you do is if it's like this, okay, you check from this cluster how far are my data points. From this point, how far are my data points? You, if it's all closer together, okay, then the sum square distance will be low. Okay, and you have to choose it in such a way that you have to, okay, in this graph, what do you think has, which k has the least sum square distance? See, obviously 9 will have the least because if I have 9 different clusters from here, 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 the distance between to those points will be low. But you don't want that many clusters because we don't have that many labels. So you select two. See, it looks like an elbow, right? Elbow. So this is why it's called the elbow method. You select two as the ideal. Okay. Should not be too high, it should not be too low, it should be somewhere in between. So two or three seems to work best. Then we are looking at hierarchical clustering. This is another clustering method. What you do is you start with the bigger cluster, okay, and then you keep going down and down into smaller cluster. This is the second approach. Okay. See, you start with big clusters like this. Okay. So this is one big cluster. This is another cluster. This is another cluster. From here, you separate it to 2 points. Okay. From here, you separate into two clusters, and you keep going until you reach individual data points. Okay. What you do is first you consider each point as a cluster A, B, C, D, E, F, G, H. You see which two pairs have the they are very similar or closer together. So B, C are close together, D, E are close together. So I'll combine this, form a cluster, combine this, form a cluster. Then I'll combine these two to form this cluster and this cluster. See, keep grouping one by one, okay, and form one big cluster based on all these points. Again, you don't need to worry about how it's done. You just have to know the concept of how it works. You either start from big cluster and keep going down to individual points, or you start with the individual points and keep going up to higher clusters. This is called agglomerative higher cluster. Divisive, as I said, start from this, divide into two, again keep dividing into two by two. So this is another thing. Okay. You start with the bigger cluster, keep going to smaller ones. So this is divisive. Again, same applications for clustering. You can use it for pattern recognition, image clustering, outlier detection, and so on. Okay. So this is clustering for now. Any doubts? Any doubts that you want to ask? You can ask it now. Or am I going too fast that you are not able to understand? Any feedback? Or am I going? Or is it too technical that you're not able to understand? I mean, any doubts you can put forward now. Okay, there are no doubts. I think we can end it now. Thank you all for joining. See you tomorrow.